Okay, today we're doing 9-3 counting outcomes, and counting outcomes is really using tree diagrams. Okay, so in many cases, there is more than one action or choice, which results in several outcomes. Tree diagrams are a useful tool to organize and show all the possible outcomes. So a tree diagram can show us all possible outcomes. All right, so we're going to use a tree diagram for number one. It says the spinner below is spun twice. So that's this spinner here. So I need to think about, okay, what are all the possible outcomes for when that happens? Well, for the first spin, okay, I can land on A, B, or C. This is my first spin. Okay, second spin, that means I'm going to branch off from each one. So from here, I can do A, B, C. After I land spin B the first time, well, after that, I can still, because I'm spinning again, this same thing, I get A, B, C. After I spin the first time, on the second time around, I can get A, B, C. So the sample space that I come up with, that's going to be found by looking at, okay, what are my possible outcomes? I can get A. We're going to list these, and then we can go from there. A, B, A, C. And then I'm going to look at my next round. B, A, B, 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 C. And then I'm going to look at the third, the C section. So I'm going to have CA, CB, and CC. And this is the list of my sample space. And now I can use this sample space to be able to answer questions. So I'm going to look to see, okay, what's the probability that B is landed on twice? So I'm looking through and I'm trying to find, okay, landed on twice. Here we go. So remember that probability, I don't have any place to write it. I'm going to write it right here. Remember, probability is what you want over the total. Well, my total possible outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9. What I want, there's only one of them. So my probability is going to be 1 over 9. All right, next, probability of at least 1A. Okay, so that means at least 1A. So the smallest amount is 1A, but I can also have 1A. So therefore, this is actually greater than or equal to, it's something that's greater than or equal to 1. At least 1A. So I have 1A here, 1A here, 1A here, 1A here, 1A here. So that's all of my possible A's. At least 1A, but I can have 2 because it says at least. So therefore, this is going to be 5 over 9 because it's what I want over the total of 9. Okay, so next it's no C's. So I can't have any C's in there. So that's going to be AA has no C's, AB has no C's, AC can't do. BA no C, BB no C, BC can't do. Oh, all of those have C's, it can't do any of these. So I have 4 that I can use out of the total of 9. And there's my probabilities. Okay, let's look at another example. We're going to flip over to the back of this page. Excuse me. And we're going to look at number 6. Okay, so we have a standard die. It is rolled. Then the spinner below is spun. So for a standard die, what we need to remember is it's numbered 1 through 6. Okay, and the spinner has 3 sections that are red, blue, and yellow. All right, so since it's numbered, so first I'm going to talk about the die. So I've got 6 spots. Okay, so I've got 1, 2, 3, 4, 5, 6. Because I've got 1, 2, 3, 4, 5, 6. Those are all the sides of the number cube. Okay. Now off of that, now after I rolled the dice, landed on a 1. Now I spin the spinner and I have 3 options here. And that's going to be red, blue, and yellow. Okay. We're going to do this so I can have room. Okay, so now here, so I'm going to have red, blue, yellow for each one. Red, blue, yellow. Red, blue, yellow. Red, blue, yellow, because after each one, those are what I can end up with. Okay. Red, blue, yellow. All right, well, I got to figure out what's my sample space. Okay, so that means I'm going 1 and then red, 1 blue, 1 yellow. So I'm going to be listing all of those out. So I have 1 red, 1 blue, 1 yellow. 2 red, 2 blue, 2 yellow. 3 red, 3 blue, 3 yellow. 4 red, 4 blue, 4 yellow. 5 red, 5 blue, 5 yellow. And last 6 red, 6 blue, 6 yellow. So this is my sample space. So if it asks for the sample space, this is what you have to write. And now we will use this sample space to figure out the probability. Okay, so the probability for a prime number. So that means I've got to, well, first I got to figure out how many total do I have. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have a total of 18. Okay, we're going to learn in just a minute also how to find out the total much quicker than having to write out the sample space. Okay, so we want prime numbers. So which ones are prime numbers over here? Okay, so we have 2, 3, 5. Because 1 is never considered an actual prime number. So I know those are my prime numbers. So it's 2, 3, 5 are the prime numbers. So that means I've got all of these that are possible, all of these that are possible, and all of these, which gives me a total of 9. But remember, we also have to always have to have a simplified fraction. So this is 1/2. All right, now we want the probability for red. Use the red pen for probability of red. So I've got to go through and figure out all the reds. Well, that's going to be this column here because that's all of my red options. So that's 1, 2, 3, 4, 5, 6 reds. So that's going to be 6 out of 18. And remember, we have to simplify, which this is going to become 1/3. And now we want at least 3. So that means it's a number that is greater than or equal to 3, which means that's going to be 3, 4, 5, or 6, then yellow. So it's got to have one of these numbers first and then yellow. Okay, so that means I've got to look at the yellow column. Okay, so it's going to be these, because they have the number 3, 4, 5, 6, and then there's the yellow. So therefore, there are 4 out of 18, which is 2/9. And that's for using the tree diagram. Now we're going to talk about how to use a quick way to find the number of possible outcomes. All right, so clicking over to here, and this is still 9/3, but this is doing the counting principle. Okay, so this is still 9/3, but it's the counting principle, the fundamental counting principle. I kind of think about that FCP. Okay. All right. You can use the counting principle to find the total number of outcomes. If one activity can occur in M ways and another activity can occur in N ways, then both activities can occur in M times N. You multiply. Multiply. Oh, I can zoom in now. Too much. Okay. All right. So let's look at this couple of examples here. All right. So it says to leave her office, Karen can choose between 3 sets of stairs and 7 doors. How many ways can she leave her office? Well, I've got 3 sets of stairs and 7 doors. So what I'm going to do is multiply those two. And when I do that, oh, I can do my work over here. 3 times 7, which gives me 21 as my answer. Okay. Jumping down. Number 4. Okay. We have a dinner that consists of 5 appetizers, 12 entrees, and 3 desserts. So I'm doing 5 times 12 times 3. It's all multiplication, so I can do whatever multiplication I want easiest. Okay, so 5 times 12 is 60. 60 times 3 is 180. So my final answer is 180. Jumping on down, because there's several that I want to talk about here. Okay, or not several, but some, just so we make sure we understand. Okay, so how many ways, we're looking at number 8 now. How many ways can someone randomly dial a 7-digit phone number? Okay, so 7 digits. I've got to think about how many digits are there. Remember, when it says digit, that's a 0 to 9. So that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means there are actually 10 digits. Okay. When it says digits, that means there's 10 of them. And I have a 7-digit phone number. 1, 2, 3, 4, 5, 6, 7. So I have 10 here that I can choose from, 10 here, 10 here, 10 here, 10 here, 10 here. Because if you think about it, you have repeated numbers in phone numbers. So you have all the digits that you can choose from. Would it all be the same number? More than likely not, but it's a possibility. And remember, and then all the way in here, we are multiplying everything. So I can either use the dot or the parentheses, which means this is 10 to the 7th. If I'm doing 10 to the 7th, that means it's got 7 zeros. So I have 1, 1, 2, 3, 1, 2, 3. There's my answer. Okay, flipping the page, moving on to the back. Okay, looking at number 12. At school cafeteria, you can choose 1 sandwich, 1 snack, and 1 drink, but you have a number of option choices. The number of drink options is equal to the number of snack options. So the number of drink options is equal to the number of snack options. Therefore, they're the same. If there are 63 ways to choose, so that means 63 is the total outcomes, the total possible. With 7 different sandwiches, how many drink options do you have? So I want to know how many drink options. Remember, drink and sandwich are the same. So if I'm thinking about this and I'm using the counting principle, I would multiply all of these options together. So I would do blank times blank, oops, jumping ahead, times blank. And that gives me the total. Okay, so I've got the drinks, I've got the snacks, and I've got the sandwich. Okay, well, what I know is that the drinks and the snacks, I don't know, but they're the same. So I'm going to put that as Y, because I can't use X. Y. Sandwiches, I know that. It tells me that somewhere, 7 right here. So I know that's 7. Do I know the total? Yes, I know the total. So I know that I can replace total with 63. So I can have 7 times x equals 63. Well, x times x, that can be rewritten as 7x squared equals 63. Yeah, 7x times x is x squared. Okay, so now I'm solving for x. So I'm going to divide by 7, and x squared equals, well, what's 63 divided by 7? That's 9. Well, now in order to get x squared by itself, I take the square root because that's how I undo squares, and x equals 3. So therefore, there are 3 drink options. Okay. A few more examples. This is a long video, guys, because there's a lot here. All right. 13. A coin is tossed 3 times. What is the probability of getting a heads just once? So we want heads once, but it's tossed 3 times. Okay, well, I've got to figure out, you need to always list, tell me what's the number of possible outcomes, and then what are the favorable, list the favorable, I can't talk, favorable outcomes, the ones that you want. Okay, so for the possible, that means that I'm doing, if it's, I have 2 options for each time. So I'm doing 2 times 2 times 2, which gives me 4 times 2, which is 8. Okay, so that means that's my total. So then I have my favorable outcomes. That means that's what I want. So if I think about that, I want heads just once, only one time. So that means I'm going to have heads, tails, tails. That's the only other option there. Tails, heads, tails, and tails, tails, heads. Now, if you can't see that right off, draw the tree diagram. Use a separate sheet of paper and draw the tree diagram to find out this favorable outcome. There's not a problem with doing that. And if you need it, I very much suggest that you do. Should have done that in purple. Excuse me. Okay. Now we're figuring out what is the probability of heads once, one time. Well, that's 1, 2, 3 out of 8. And there's my answer. Okay. Jumping down to 17. What is the probability of getting yellow and an even number? All right, we got to do the possible outcomes. How many possible outcomes? So that's going to be yellow. So that's this spinner. There's 1, 2, 3, 4, 5 options times an even number. So this is this spinner down here. 1, 2, 3, 4, 5, 6, 7, 8. So I'm doing 5 times 8. So that gives me a total of 40. 40 is my total possible outcomes. So next I need to figure out what's my favorable outcomes. I've got to list those. So it's yellow and an even number. So I'm going to have, it's going to have to be yellow for sure in all of them. And then I'm going to have, you're going to have yellow 2, yellow 4, and yellow 6. And, oh, forgot yellow 8. Yellow 8, so that's 4 outcomes. So the probability of yellow and even is going to be 4 out of 40, but that's not simplified. My final answer is 1 out of 10. This is that probability. Okay, your assignment is to finish the notes and the classwork homework. Okay, have a great day. Bye.